Now that we've learned about simple machines, let's focus just on levers. There are three types of levers. A little bit about the history of a lever. Levers are one of the basic tools that were probably used in prehistoric times, probably one of the first tools ever used by mankind. They were first described, however, in 260 BC by the ancient Greek mathematician Archimedes. The definition of a lever is a simple machine that makes work easier by moving a load around a pivot using a force. So we're going to use some terms throughout these simple machine units that you kind of need to understand. The first one of those terms is load. The load is the object that you're moving. It's also known as the resistance, and sometimes it's referred to as the output. Pivot is another term. That's also known as the fulcrum. So many of our basic tools use levers, including scissors, which are first-class levers, pliers, which are first-class levers, the claw end of a hammer, which is a first-class lever, and tongs, which are third-class levers. A first-class lever is identified because it has the fulcrum between the effort and the load. One of the things you need to know for this unit is how to identify the difference between first, second, and third-class levers. So I'm going to give you a hint. The hint for this is to remember first fulcrum. If you can remember that both of those start with F, you should be good to go. First fulcrum. So the fulcrum is in the middle. All my hints deal with what goes in the middle. So here's a nice diagram that helps you understand the difference between effort, fulcrum, and load. The effort is the part that you do. This is, you can see here, where the hand is. It's also known as the input. The fulcrum is usually represented with a triangle because it's a pivot point. You can rock on that. And the load, you can see down here, is represented with a box because that's what the object is that you're trying to move. This is also where the output occurs. It's also known as the resistance. So we've got input or effort and output or resistance. A second-class lever has the fulcrum at one end, while the load is in between the fulcrum and the effort. So here you can see the load, the object we're moving, has moved into the middle. If you added a barrel to this and you made the fulcrum a wheel, this would kind of look like a wheelbarrow. Your hint for remembering the second-class lever is remember second-class ELF. Remember the word ELF. If you can spell the word ELF, you see it goes effort, load, fulcrum. So the load is in the middle. That's what you need to remember to get the second-class lever. A third-class lever also has the fulcrum on one end, but this time you switch the effort and the load. Here you see the effort is between the fulcrum and the load. If we added another lever and put the load in the middle, then you can see this kind of looks like a pair of tweezers. The third-class lever is the least efficient lever. And your hint to remember what's in the middle of a third-class lever is 3E. That's your hint because 3 rhymes with E. So 3 for third class, E for effort in the middle. And remember, the effort is the force that you apply to the machine. So let's do some identification. For each of the pictures that follow, we're going to label the effort, the fulcrum, and the load. Remember, the effort is where you apply force, the fulcrum is the pivot point, and the load is where the object applies the force. Then we're going to identify the lever as a first, second, or third class lever. So here we have a pair of nail clippers. Sometimes it's easiest to start with the effort. Where do you apply the force? You apply the force right here. So that's the effort. Where's the fulcrum or the pivot point? The pivot point is right there in the middle. And where's the load? The load is right here where you would actually clip the nail. So now we can see what class of lever is this. Well, we've got load on one side, fulcrum in the middle, effort at the end. This is a first-class lever. Okay, something new. Here we have a nutcracker. The effort is again at this end. The fulcrum, we actually have two fulcrum points, is down here at this end, right here where the two levers pivot. And the load, in this case the object we're trying to move is the walnut, so the load is in the middle. So if we look at this, we can see we have effort, load, fulcrum, loads in the middle. That spells the word ELF, so that must mean it's a second-class lever. And our final lever is the bottle opener. Let's take a look at this. This one's kind of tricky. If the effort part is easy to see, this is where you apply the force down here at the end. Now we need to figure out which part is the fulcrum and which part is the load. Where does the bottle opener rock? The bottle opener's fulcrum is here, where the opener kind of rocks on the cap. And that means the load is here, where it pushes up on the cap of the bottle. So we have ELF. That means this is also a second-class lever. If you have any questions about types of levers, let me know.